We will continue 7.2 and we will finish it inshallah, and then practice by solving the recitation questions, the recitation exercises. So let's recall together, Shabab, what is this section is about. Mainly it is about the integrals of trigonometric functions. So this is why we call it trigonometric integrals. So it is about when the integrand function, when the inside function, the integrand function is a trigonometric function, or a combination, of course, of some trigonometric functions. But mainly we are concerned about when we have a product of powers of sine and cosine, tangent and secant, and so on. Okay, but of course we could have also other type of trigonometric functions and combination of several. And if you remember, the ideas is use the identities. Mainly it is about how to use identities and use substitution. So think about a trigonometric function, trigonometric identity. Think about what will be u, what will be du, just like that. So it is natural to write the odd powers as a product of even power and then du. So this is your du. Now you should think about looking for u. If this is du, what will be u? U will be sine. So try to get sine from here. Try to write this in terms of sine, and this is the idea. Just use trigonometric identities, then use substitution. Similarly here, log sine to the power 5, write it as sine to the power 2 or 2 multiplied by sine. Now this is your du. Think about u will be cosine. So you need to write or express all the terms here in terms of cosine, and that's it. We have set up a strategy how to evaluate that. Of course, you need just to look if the cosine is, if the power of cosine is odd or the cosine of sine is odd. Which one of them is odd? The one that is odd, save one cosine factor and use it for du. Okay, in the case of sine, save it for du, the sine. Here you will put u equals sine, here you will put u equals cosine. If both of them are odd, then use A or B. What is different, a little bit different, when both of them are even. In this case, you need to use the half angle identities. The previous techniques does not work. You need to use the half angle identities, as we did in this example, if you remember in the previous class. Similar strategy can be used for tangent and secant, but of course here the derivatives here are a little bit different. So the idea here, if you have the power of secant is even, then save a factor of secant squared. Why secant squared? Because the derivative of tan, it is secant squared. So this is going to be your, this is going to be du. And you have to look here for u. U will be secant, tan. Now try to express your integrand now in terms of tangent. And this is what you need to do. You need to use the trigonometric identities. Now this is u, this is du, khalas. It is a matter of integrating very easily. And also the strategy here, we set up a strategy that could be, of course, that can help you to integrate. If the power of secant is even, save secant squared factor. If the power of tangent is odd, save secant tan. And in this case, you know that secant x tangent x, it is the derivative of secant. So you will put u equals to secant in this case. And you will express your integrand in terms of secant, because this is the integrand, and this of course will be a function of u, and this is du. So you have the integral of f of u du. When you have only tan to the power even, when the power is even and you only have tan, then in this case you need to convert to save a factor of tan squared and then convert it to secant squared minus 1. In the case of secant, this is the only difference case, Shabab. Here, this is the case that you need to pay special attention. When you have secant to the power odd, when the power of secant is alone and it is odd, in this case, you need to do integration by parts, as we will see in example number 8. If these 4 guidelines don't apply, try to convert to sine and cosine. You know, ya Shabab, that all the trigonometric functions are coming from sine and cosine. You know that. Tan, it is sine over cosine. Cotangent, it is cosine over sine. Secant, it is 1 over cosine. Cosecant, it is 1 over sine. What we said about tangent and and secant can be also used for cotangent and cosecant integrals like that. We solved this example. I will not go over it again. Also, I have reminded you here about what is the integral of tan, what is the integral of cotangent, and what was new in the previous class are these two integrals. What is the integral of secant? What is the integral of cosecant? Okay. Now, I think also we did this in the previous class. It is not difficult here to write it as tan squared. Now this will be secant squared, and of course expand. This will be u du, and this integral, you know how to do it. I think with you, ya shabab, also we solved this example. Am I right? I think we did solve for you. Let's go over it quickly. So how we integrate, we evaluate this integral. Now, this is the case that I told you about. This is example number 8. We have secant, only secant, and it is to the power odd. In this case, we will use the integration by parts. But before that, we need to write it as secant x times secant squared x. Now, ya shabab, if you think about any u substitution, it will not work. For example, some of you, they like to use, for example, u equals to secant x dx, secant x. In this case, you know that du will be secant x tan x. And unfortunately, du is not here. You don't have tangent. If you put it secant squared, it will be more complicated because it will be, if you put it u equals to secant squared, then the derivative will be 2 secant squared tan. It will be more complicated, and it is not there. So the u substitution doesn't work this way. Even if you think about putting it as tan, for example, some of you, they say, why we put this as tan? Let's say, for example, let's put this as tan squared x plus 1 dx. What will be the benefit? You will be able to evaluate the next integral, and here you will have secant x dx. Now you need to go to do back here. You have secant x, you can integrate this one. This one also, the u substitution doesn't work. And you need to go back to write it as secant squared minus 1, and you will go back to this integral back again. No benefit of that. Because here, if you put u equals to tan, du will be secant squared, and you don't have secant squared, you have tan secant only. So this is why try, shabab, to think about it in many different ways. You will find, of course, that you need to decide about using integration by parts. So also it is important to think what should be u, what should be dv. Try this, try that. So of course, because this is easier to be dv, because you know that if dv is secant squared, then v is tangent x. So it is direct and easy. If you think about the another way, you know that the integral of secant, it is ln the absolute value of secant x. If you put dv equals to secant x, then of course secant x dx, then v will be ln the absolute value of, and this will be not easy to be integrate in the next integral. So it is not practical to do this. So the best choice is to put u equals to secant and dv to secant squared x dx. Now differentiate u, integrate dv, and then multiply uv minus v du by parts. We have the following. Now here, unfortunately, we don't have a simpler integral. It is not simpler than this one, but at least it is not more difficult than this one. Because what we can do here, we can do what we were thinking about at the beginning, to put tan squared as secant squared minus 1, to use the Pythagorean identities. Now, if you expand, look what will happen now. You will multiply secant by secant, it will be secant cubed. Negative times negative, it will be positive. Secant times 1 is secant. This integral is easy, we can integrate it. And look at this. This is the same integral that we have at the beginning. So now we can add this integral to both sides to have 2 of this integral. So just I will I will remove or add this for both sides. Indeed, what we have here I, and this is I. This is the same integral. So we will have I equals to this integral minus I plus this integral. So we will add I for both sides. This will be cancelled, and we will have 2I here. So we have 2 of the integral that we are looking for equals to this. Now what we need to do, we just divide by what? By 2 to find the exact value of this integral. And as one of you asked in the previous class, where is 2 here? Why we didn't divide by 2 here? And I think I have answered this question. The idea here that it is the same constant, it is not the same constant. It is a constant. So it is any constant. So you can write it, by the way, if you want, you can write it, no problem. It will be accepted. You can also write it like C1. You can say also that it is C1, and you can say here C1, it is C, the old C over 2. It's okay. At the end, it is just a constant of the integration process. I think also with you, I have mentioned this in the previous class, but let's do it again, Shabab, because I will record this video for the other sections. So if you have integral, what we did before, Shabab, we were talking about the integral of sine to the power n, let's say x, and cosine to the power n x. Look here, we have the same argument, the same angle, but different powers, okay? What about if we have a product of sine and cosine, or a product of sine and sine, or a product of cosine and cosine, but with different arguments, with different angles? And it is just not about the double angle or the half angle. No, you can use for those identities, you can use identities. When you have a product of sine and cosine, sine or sine, cosine or cosine of different angles, then you need to use these identities or these formulas. They are called, ya shabab, product identities. How to convert products to sum and difference. So product to sum and difference identities. And they are coming, by the way, they are coming from the cosine of the sum and the cosine of the difference. Similarly also, you can obtain them from these identities. If you recall them, just it is a matter of adding and subtracting some identities from others, you will get these. They are not difficult to be memorized, ya shabab. Look, the best one that you have no effort to recall it is this one. Look, cosine A, cosine B, it is the half of cosine the difference plus cosine the sum. So it is cosine, 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 everything. So this is done. I think no one will forget this one. Now for these two, if you have sine, sine, if you have sine, sine, you have cosine, cosine. Different from if they are both the same. And it is difference. So when you have sine, sine, it is the only case that you have minus. Now if they are different, here it will be sine. And it is still the sum. Each one of you, Shabab, can find his own way to memorize this. So now let's apply this for this example. I think here we need to do what? We need to apply the formula number A, this one. Just use this one. So here the integral will be equals to the half of sine the difference. The difference here, this is A, this is B. The order here, Shabab, is important. So A here, it is the angle of the argument of sine, and B here, it is the argument of cosine. So A minus B for x minus 5x, it is negative x, and 4 plus 5, it is 9x. Now, because sine is, it is an odd function, this negative will go out. It will be negative sine x plus sine and x dx, okay? Now, what is the integral? This negative also can be out. Now, let me ask you, Shabab, some of you to help me with this. What is the integral of negative sine x dx? What is this integral, ya Abdul Latif al-Milham? Abdul Latif.
Yes, doctor.
What is the integral of negative sine x dx?
Cosine x.
It is what?
Cosine x.
Cosine x. Why? Because it is the negative will go out. We will have the negative out. Thank you, Abdul Latif. And we will have like this. equals to negative the integral of sine x dx, if you want to think about it in a different way. The integral of sine, shabab, is negative cosine. Be careful, don't mix up between the derivatives and the integrals of sine and cosine. And it will be negative times negative is positive, and as Abdul Latif said, it is cosine. So thank you, Abdul Latif. The integral of this one, it is cosine. We have a half here, so this will be cosine x. Now let me ask another one. Let me ask Muhammad Al-Yami. Yeah, Muhammad, what is the integral of 9 sine 9x dx?
Minus 1 over 9 cosine of x.
Cosine 9x.
9x, sorry, yeah, 9x.
The integral of sine, shabab, is negative cosine 9, and this 9 is coming from the u substitution. If you put u equals to 9x, you will have 1 over 9. So just we save it, we save the derivative here. Because the derivative of the inner function is 9, we divide by 9. Thank you, Muhammad. Now, the last part, and it is important trick, I want you to have an idea about it. If you have integral like this, how can you deal with it? Unfortunately, there is no examples in your textbook about this, but there are some exercises, I think. So, what do you think?
Can we use half angle identity?
Yes, ya Walid. Yes, exactly. Yeah, Shabab, you remember how to integrate cosine squared theta, for example, d theta. You remember?
One
the same for sine. We will use 1 plus cosine, the double of theta. And this identity, it is called the reducing power identity or the half angle identity, whatever. Okay? So now what we have here, we have the opposite. We have cosine squared theta equals to 1 plus cosine 2 theta over 2. Now, if you multiply both sides by 2, look what we have. So when you have 1 plus cosine 2 theta, you can write it as 2 cosine squared theta. So this is the identity that I need here. So what we will do here, we will write this as the integral of the square root of, what is 1 plus cosine for x? Let me ask Badr al-Haboubi or Muhammad Ilyas al-Khreshi. Ilyas, are you with us, Ilyas?
Yes, doctor.
Yalla, 1 plus cosine for x will be what? According to this formula.
Will be 4 cosine theta.
It will be 2 cosine squared what?
2 theta.
2x dx. Ahsant, Ilyas. Yes, you're right. If you have here 2 theta, here you will have theta. If you have here 4x, here you will have 2x. Yes, it is the half angle. Yes, excellent. Ahsant, Ilyas. Muhammad al-Musa.
Hello, Doctor.
Yalla, how to continue, Muhammad? This is equals to what? Square root of 2 cosine squared, ya shabab, the square root of cosine squared 2x dx. What is this, ya Muhammad?
هذه square root of cosine the cosine square x 2x, sorry.
So it will be cosine 2x, this one?
Raised to the power half.
To the power, it is cosine squared, ya Muhammad.
Oh, okay. Cosine 2x, because the square will go with the x.
Yes, when you have a square root of the square root of y squared, ya Muhammad, it is equals to what?
Y. The absolute value of y.
The absolute value of y, yes. So here, be careful, shabab. By the way, you are lucky here. It was cosine, by the way. But in fact, in general, it is cosine 2x. Okay? But you were lucky here because look, what is your interval? Now, where is x? X is between 0 and
0 and pi over 4.
Then 2x will be where? This 2x, the angle, will be between what? Multiply both sides by 2. It will be between 0 and pi over 2. In which quadrant? 2x. It is
in the first
1.
quadrant.
In the first quadrant, cosine is what?
The first quadrant, it's positive.
Cosine here is positive. Okay? So because cosine is positive, no need for the absolute value. So cosine 2x will be positive or 0 in the first quadrant, if you consider it like that. Okay, now we are done, ya shabab. You know how to integrate cosine. So this will be the square root of, what is the integral of cosine to x? What is the integral?
1
This will be
over
the
2.
integral. Let me write the square root out here. It will be cosine to x dx, and don't forget to write the square root here out. It will be the square root of what, yeah, Muhammad, what you said?
1 over 2 sine to x.
Sine to x. You are sure about, we don't have negative here? You are right.
No.
I know. Yes, you are right. The integral of cosine is positive sign, but the derivative of cosine is negative sign. Okay. Excellent. Now, you know, Shabab, how to continue, but please practice. Don't say I can do it. No, do it, because it is important to practice the calculations. You have a multiple choice exam, so it is important. These are additional exercises for you with the final answer, so please practice by solving them and check your answer. These are also some suggested problems. We will solve now these recitation exercises. Let's start with the first one. I will give you, ya shabab, 1 minute or 2 minutes to think about it and share with me your ideas, how to solve this one. Take your time. Please, ya shabab, take a pen and paper and start work. Please turn on your thinking, turn on your brain to start to practice. If you are in a class and you are not thinking, so you are not learning. If you are not thinking, you are not learning. Imagine that this is a question in a quiz or in a test or in an exam. You have a real question. What you will do? Of course, you have to think about something. It may work, it may not, but at least you try. Don't be afraid from doing mistakes inside the class. I repeat this every time. Share with us your idea, but if it is okay, if it is correct, this is good. If it is not, no problem. Just I want you to think loudly. Badr Haboubi, do you have an idea about this? What you are thinking about, yeah, Badr?
Well, first of all, I try to maybe change the cosine square to 1 minus sine squared.
Not bad. Let's do it.
At the beginning, I thought maybe I can cancel the sine, the cotan, but right now I'm still working on it and I don't know.
So, one by one, ya Muhammad. One by one, ya Badr. You said we will write cosine squared as 1 minus sine squared. It is not a bad idea. It might work, it might not. What you said again, what else? What about cotan? What you will do?
I wanted to, cotan is cosine over sine. I wanted to see what I can do, maybe cancel the sine, but I don't know what to do.
You are right. This is the solution. You did it. So cotan, it is cosine x over sine x. So you did it two in one, by the way. In the previous classes, I did it in 2 steps. You did it in 1 step. So, ya shabab, you have to trust yourself. You have to trust your ideas. Okay? So let me write this again. This is cosine x over sine x. Now what we will do, ya shabab? خلاص ya Badr, thank you. I will ask Ali Sani. Ya Ali, what do you think? What we can do?
Maybe separate sine over 1, multiply cosine over sine by the brackets.
Then what is the benefit of that? There is no cancellation. It will not be that important. It is not good, not bad, by the way. What Ali is thinking about is to write it as cosine x over sine x minus cosine x sine x. Okay, when you multiply, sine will be cancelled here. So it is not bad. You can integrate this because you can integrate cotan.
And
This
you
will
can integrate
cosine x over sine x. It is the integral of cotan, and you know that the integral of cotan is what?
ln of
it is ln of sine.
sine, yes.
minus, this will be cosine x sine x. You can use here what?
What the substitution?
No substitution. You can put sine as u,
Yes.
and this will be du. So it will be negative sine squared x over x plus c. You solve it. You did it.
Yes.
Ya shabab, believe in your abilities. Believe in yourself. Yes, you did it. Excellent. So this is exactly what you can do. So this is the integral of cosine x over sine x. I will write it here for you. Minus sine x dx. And this is equals to ln sine x, because by the use substitution, minus, this is of course we have here cosine also, x dx. So this will be u squared or sine squared x over 2 plus c. Indeed, what I did with the previous class in Shabab is this. We put here, or this is another way, but it is the same way. What we did, we just put u equals to sine x from the beginning here. Look, notice if you have sine x, then du will be equals to cosine x dx. And in this case, this integral will be what? This integral will be the integral of u, this is u, this is 1 minus u squared, and cosine x dx, it is du. So we have here, let's write it here, 1 minus du, and usually we write du here. Here we are. So now this is equals to what? The integral of 1 over u squared minus u squared over u, it is u, du. And this is the same as this, Shabab. It is the same as this one. Now, if you integrate this, it will be 1 over u. I prefer, Shabab, to write brackets here to avoid any mistake. This will be what, Shabab? What is the integral of 1 over u? It is ln the absolute value of u minus the integral of u, it is u squared over 2 plus c. What is u? U is what? Sine x minus sine squared x over 2 plus c, which is the same. Great, ya shabab. Let's go to the next exercise. Again, I will give you 1 to 2 minutes to think about it. 2 minutes, no problem. And I will ask some of you to share their ideas with me, with us, with all of us. Yes, you are thinking loudly, Ali. Really, we can hear your thinking now. Good, 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 good. Please, ya shabab, pen and paper and practice. Yusuf Al-Hajjuj, do you have an idea what you are thinking about, Yusuf?
Yes. I'm thinking to write it as a cosine multiplied by the secant square.
Again, cotan. What is cotan?
Oh, I mean tan.
Good idea.
Yeah.
So you are thinking about this, Yusuf. You are thinking about writing it as sine phi over cosine phi, and this will be tan.
Yes.
And what is remaining here? 1 over what? 1 over cosine
1
squared
over cosine squared.
phi d phi, and this will be secant
Yes.
squared phi. Is this what you meant?
Yes.
Great, you solve it. You integrate, mashallah. You are integral man. Good. Now, what we will do next, Muhammad Ibrahim. Muhammad Ibrahim, if we have this integral, how to find it?
Take u tan and you.
This is just the integral of u du. You are right, Muhammad. This is u, and this is du. So it will be u squared over 2 plus c. It will be a half of u. What is u? Tan. Tan squared phi plus c. Thank you, guys. MashaAllah alaykum. Great. Who has another idea, Shabab? Let me ask Badal قعدت. Yeah, Badal, do you have another idea? Did you solve it in a different way? Is there
No,
anyone
no,
in the
doctor.
job?
I
Yes.
solved it in the same idea.
Badal, in the same idea. Good answer. Very smart answer. Good. Okay. Anyone in Shabab had another idea? In fact, it should be
Yes.
this is not the direct idea. The direct idea is يا شباب the another method. Yes, who said? نواف.
Yes, Doctor. Let cosine equal you.
الله يرضى عليك يا نواف يا أخي ما شاء الله عليك. Yes.
Thank you.
كان طبيعي يا شباب من البداية أنكم تفكروا بالطريقة هاي مو بهاي ترى ما هي الطريقة المباشرة. أنت if you put u equals to cosine phi إيش راح يكون الدي u؟ negative sine phi. Am I right?
Yes.
Now this integral, let's call it I. This integral will be what? What is in the denominator will be u to the power 3. And here we have sine theta d theta. Sine theta or sine phi d phi. It is negative du. Now this is going to be negative. The integral of u to the power negative du, which will be equals to negative u to the power. Add 1 and divide by the new power. Plus c. Equals to a half. Negative of negative 1 over u squared plus c, which will be a half 1 over cosine squared phi, because this is u, equals to a half 1 over cosine squared, it is secant squared phi plus c. The problem here يا شباب is that this value or this value, it is not the same. So which one of them is correct? Which one of them is wrong? Is there a problem?
Both of them right.
Both of them are right, and you are also right. But why they are they look different? Why they look different, Shabab? They look different. What is the problem?
Because some of them have two different.
Because if you put c equal to 1, we can get tan square.
They are the same, Shabab. Look, take one of them. Take this one. A half secant squared phi plus c. It is equals to what? A half. What is secant? Secant, it is 1 plus tan squared phi. Do you recall that? Plus c. This is equals to tan squared phi, a half. Let's write a half tan squared phi plus a half plus c. So this is equals to the half of tan squared phi plus another constant. Let's call it c1, for example. So because of that, we write c, Shabab. It doesn't matter. You can write this one c1, no problem, or this one c2. But at the end, they are the same because secant squared can be written in terms of tan. But in some situations, they may ask you about this specific constant. If you have initial value problem or boundary value problem, you can, of course, find what is exactly this constant. But here we are finding the most general antiderivative. It doesn't matter. So they are the same, ya Shabab, with the help of the trigonometric identities. I mentioned the both answers here for you, because some of you, they may solve it this way or that way. Don't worry about the constant. Yes, it is not the same, but it is just a constant. Okay, now how to evaluate this integral? I think you know now. Who can tell me what is cosine A, cosine B, Shabab? Who has a good memory?
Doctor, the same. Both of them are cosine, and then we take the
All of them
difference.
are the same. Yes, this is what I told you about, that it is not, you cannot forget this. It's so easy, so clear. So here we are, Shabab. These are the identities. So you need just to pay special attention now to these two. For this one, it is clear. Now apply it. So what you will have? It will be the integral from 0 to pi over 2, a half of what? Cosine. The difference is 5 minus 10. So it is negative 5t plus cosine of the sum. What is the sum? 15t. All, of course, dt. Now this is equal to the half outside. What is the cosine negative phi, Shabab? It is what? It is cosine
1 over
phi.
5. 1 over 5 sine.
No. Wait a minute. I'm
Theta.
asking now about the negative sign inside. Cosine negative 5t It is the same as negative as cosine t.
Even function, yes.
Cosine 5t, because it is even. Because it is even function. So we have now this integral. This integral equals to what? What is the integral? It will be the half of. What is the integral of cosine 5t? Yeah, Muhannad Halabi. What is the integral of cosine 5t dt?
It's sine over 5. Sine 5t over 5.
5 over t over 5. There is no negative here?
No.
No negative, you are right. So it is 1 over 5 sine 5t. And similarly, we will have plus 1 over 15 sine 15t. From where to where? From 0 to pi over 2. Don't think that it is easy from here. Yes, it is, but you need to practice, Shabab. Please, when you study at home, practice by solving, by evaluating the final answer until you get the final answer, because this is what is important. You may do all of this work and you make a mistake at the end. Let me show you this example, specific example. Here we will have a half of 1 over 5. If you substitute by the upper, it will be sine 5 pi over 2 plus 1 over 15 sine 15 pi over 2 minus sine 0 is 0, sine 0 is 0, so minus 0. Okay, now it is equals to the half times the 1 over 5. What is sine 5 pi over 2? You know that because it is pi over 2 here, it will be positive or negative 1?
Positive 1.
How to know? This will be sine 5 pi over 2 minus 2 pi. You will subtract 2 pi. You will find, Shabab, the reference angle. Do you remember how to find the coterminal and the reference angles, MATH102? So now this will be 5 pi minus 4 pi. It will be 5 sine pi over 2. If you want to know, just we subtract. Let me write it for you. It's okay. I think most of you, they know it. So it will be sine pi over 2 plus 1 over 15. Now this will be sine what? 15 pi over 2. What you will do, it will be sine 15 pi over 2. It is not enough here to subtract 2 pi. So we need to subtract 4 pi, I think. What do you think? Is it enough to subtract 4 pi only? It is not enough also, because it is still less than 15 and you still have 6 pi. You can try 6 pi. You will subtract 360 degrees again. So now I think it is enough, because 2 times 16 will be what? 13. 15 minus 13 is what? 3 pi. It will be 15 minus 12. It will be 3 pi over 2. And here we are. This is equals to the half of 1 over 5. What is sine pi over 2?
1.
1. Plus 1 over 15. What is the sine of 3 pi over 2?
Minus 1.
Negative 1. So this will be the half of 1 over 5 minus 1 over 15, which will be equals to 1 over 2 multiplied by, here you multiply by 3, here you multiply by 1. So it will be 3 minus 1, it will be 2 over 15, which will be 1 over 15. If we are lucky, we will get the right answer. This is the integral. I write it here for you to check your answer. And it is 1 over 15. Alhamdulillah, we are lucky because we did it slowly and we focused. We try to focus on everything here, especially the signs, positive, negative, and these issues. I always ask, tell my students that ليأخذ الدرجات هي الإشارات. Okay, now I will give you again 2 minutes to solve or to find the volume obtained by rotating the region bounded by the following curves: sine x, cosine x, x between 0 and y over 4, and the rotation is about the line y equals 1. You know, Shabab, what you should do in such case. This is a good question when you have a combination of sections in one question. Your task now is to find the volume, and you know the volume will be the integral from some number to another number for some function here, d with respect to a variable, with respect to x or with respect to y. So you have 4 tasks that you need to do, 4 question marks that you need to answer. You will integrate with respect to what, and from where to where, and what you will integrate. To answer these questions, you need to sketch the region. It is the best way to do that. Sketch the region and you will be able to decide. Please يا شباب, take a pen and paper and practice. This is 6.2, 6.3. يا مهند يا مشعل العقيلي, can you think loudly? يعني can you share with us what you are thinking about? مشعل ممكن فكر بصوت عالي, يعني سمعنا صوت تفكيرك.
Really, I'm trying, but I don't know.
لا تقول I don't know, قول لي I'm trying, it is okay.
Oh, yes, I'm trying. Now I'm trying in the bed.
What you are trying, what you are doing. Just share with us what you are doing now.
The derivative of I mean the integral of sine.
شوية على الانتجرال. احنا في أول خطوة لما يجيك سؤال عن الفوليوم إيش أول حاجة تسويها؟
Draw the graph.
Yeah, طيب رسمت؟
Yes.
طيب. You know how to sketch the graph of sine and you know how to sketch the graph of cosine. It is not difficult. So this is the first thing that you need to do يا شباب. This is the x-axis, the y-axis. فالشباب اللي ما رسموا صح, this is the origin. تدروا هذه الساين. This is pi over 2 and this is pi, I think pi. Let's take it like this. And you know that my x is between 0 and pi over 4. So this is pi over 2 and this is pi over 4. Let's say this is pi over 4. This is sine. Cosine, it is 1. It is 1 at 0. So it is 0 at pi over 2. So it is like this. And you know that the intersection points, sine and cosine, they are equal to each other at pi over 4. So this is the region that he is talking about. The region that we are looking for is this one. And I have a figure here for it. So this is the first step يا شباب. Did you sketch the region in the right way? If you didn't, خلاص راح منك السؤال. Okay? So it is important to sketch the region in the right way. Thank you يا مشعل.
يا دكتور عندي سؤال.
يا مشعل, thank you. Let me ask another student. مهند بإسماعيل.
Yes.
إيش رأيك الحين? Which method we will use?
I think the washer method because
ليش الواشرز مش الشيلز? You prefer the shells.
shells we will draw a parallel line to the axis of rotation.
طيب وش المشكلة لو رسمنا parallel line to the axis of rotation؟ هذا الأكسس of rotation. So what will happen if we draw a line parallel to it? The problem is that this line will not be the same curve from the right and from the left يا شباب. لاحظوا معاي. If we sketch the line here or here or here, the curve on the right is not the same. You have to do two integrals in this case. If you want to integrate here يا شباب with respect to with respect to y, يعني I'm talking by the shells method, you need to integrate here from 0 to square root of 2 over 2, which is the value of the functions at pi over 4. Then from square root of 2 over 2 to 1. So you have to do two integrals. And it is not, I don't advise you to do that. So what you should do is to think about exactly what Muhammad said. Muhammad said by washers. ليش by washers يا شباب? By washers we will not draw parallel line. We will draw perpendicular. هذا البربنديكولار اللي راح نرسمه. خليني أخليه هنا شوي. هذا اللاين. So of course, if it is here or here or here, it doesn't matter. What is above, it is still above curve. What is below, it is below. So the y upper, y lower are the same curves. They didn't change. So I need just one integral. So this is what we are going to do. This line, يا شباب, that I draw now, it is perpendicular to what? To the x-axis. So we will integrate with respect to what? X. With respect to x. So this is the first answer of the 4 question marks here. So now I will find my volume by integrating with respect to x. with respect to x, I will integrate. X is from where to where? You look, where is x start? Start at 0 and stop at pi over 4. So I will integrate from 0 to pi over 4. Now the question is what I will integrate here. What I will integrate? We say that we will not use shells, we will use washers. So if you know, when we use washers, by the way, Shabab, is it a disk or a washer? If we rotate here, the cross section is washer. Why? Because look here, because of this gap here, because of this space here, it will be, of course, because it is not solid. That is, the axis of rotation is not a boundary for the region from the beginning until the end. Okay, so there is a gap between the region and the axis of rotation. So we have a washer, and you know, when we have a washer, the area of the cross section will be multiplied by the outer radius squared minus the inner radius squared. Here it is, this one. Now the task is to find the outer radius and the inner radius, R capital and R small. And you know how to do that. I taught you how to do that. What you will do, you will draw a line from the line of rotation to the closest curve or the closest boundary of the region. So this will be R small. So where to write it here? This will be R small, the inner, the shorter is the inner in this case. It is not in general, it could be the longer one, it depends. Now, the longer one from the axis from here to the lower one, to the lower curve, this will be R capital. So R of x here will be what, ya shabab? It will be this point minus this point. So it will be 1, y here is 1, y here is cosine. So it will be 1 minus cosine x. And what will be R capital, R of x?
1 minus
R of x will be this point. What is y here? Y here is 1 minus what is y here? Y here is sine. So here we are. Now this integral will be, let's get the pi out. So this will be pi, the integral from 0 to pi over 4. For what? R, it is 1 minus sine x all squared minus small r, which is 1 minus cosine x all squared dx. Halas, you did it. If you have done this, you will be able to integrate. So what you will do, just you will expand your integral. So what we will have here, we will have 1 minus 2 sine x plus sine squared x minus, here you need to be careful because you have negative sign. So let's expand and then distribute by -1 at the same time. Be careful. So it will be -1 squared minus by minus, it will be plus 2 cosine x, and it will be plus cosine squared multiplied by negative, it will be minus cosine squared dx, all dx, of course. Now simplify, it will be by the integral from 0 to pi over 4. 1 with -1, they will be cancelled. You have negative sine x plus 2 cosine x plus sine squared x minus cosine squared x dx. Now, what we can do, this is easy to be integrated. Sine x, you know how to integrate sine, you know how to integrate cosine. Also, you know, Shabab, how to integrate sine squared and cosine squared. It is not difficult. You can use the half angle identities, but did you realize what is this?
Yes, I remember that.
Minus cosine 2x.
Sine square minus cosine square
cosine
equal.
to x equals to cosine squared x minus sine squared x. So this is just what?
Minus
this is the
cosine.
negative of cosine to x. Am I right?
Yes.
So
Yes.
it is here, Shabab. I did it for you, by the way. If you want to practice and check, here it is. Look, from where this is coming, this one, the negative, it is coming from here. This is negative sign, here it is. This is 2 cosine, here it is. And now you can integrate. By the way, this brings to me this question. What is the integral of sine squared x plus cosine squared x dx? Who can find this integral, Shabab?
X.
X.
It is x plus c.
1. Yes.
Yes, because it is just the integral of 1, the integral of 1 dx equals to x plus c. Thank you, Shabab. This is all what we have for today, and see you inshallah Next class, we will inshallah start 7.3 next class.